In a new study published in Astronomy and Astrophysics, scientists have examined a star which is behaving very strangely and determined that the most likely explanation is that the space between us and the star is being temporarily warped due to two stars which lie in the line of sight but are invisible to us. Let's break this article down and see if we can work out what might be going on. In the summer of 2016, astronomers observed a star which was approximately 2,500 light years away in the Cygnus constellation, and it flashed to life as if preparing to explode in a fiery supernova explosion. When they observed the star the following day, it had dimmed back to normal. Then a few weeks later, this process repeated itself. It brightened and then dimmed within a day. They continued to observe the star, and over the following year saw this process repeat 5 times within 500 days. And this presents a problem, as stars in the fusion model cannot undergo such rapid changes and cannot simply halt a supernova explosion as this star seems to have done. It is much better to have this star behaving normally. So this is exactly what they concluded. The star was behaving normally, and instead a pair of meddlesome binary stars was warping the space in front of this star, creating a temporary lensing effect, periodically magnifying the light from the star behind it. But these objects were so small that actually they were not visible from Earth. Worse still, they worked out that this binary pair must be creating pockets of magnification. And this implied that these were not supergiant stars capable of warping space-time, but instead were a small pair of red dwarfs roughly half to a third the size of our Sun. Let's start with the most obvious problem I have. Two small stars, smaller than the Sun, are now capable of creating lensing effects? How exactly is that possible? I mean, if this was possible, then pretty much every star in the sky would create a lensing effect. And this would mean that if we looked out at the night sky, we would never see the same image. As the stars move and change position, we would see distortions and brightening events going on all of the time. In fact, we should see this even from large planets like Jupiter. But we don't. The next problem is the periodicity. If this is created by a binary pair, their orbit is regular, and this means that the brightening events should be spaced equally apart. Yet they are not. The first two came within weeks, then a longer period, followed by an even longer period of time. And they have computed a very complex path that these pair would traverse in order to create the pattern we see. When I examine the graphs of the data, I do not see this periodicity. I see an increasing strength, and then a long pause and a significant reduction in brightening. And the other important point is that the first two events are very sharp, and then the latter events take much longer to appear and much longer to go away. Now, this could be explained by the fact that this binary pair is slowly moving away and therefore the lensing effect becomes less. Yes, absolutely. And again, the problem here is if that is the case, we would never see this repeat again. So this could be a one-off event that we see because it just so happens that these pass in front of it. So it's a lucky coincidence. But again, I would say if we are calculating that this should be a binary orbit, that we should at least be able to see one complete cycle of that orbit. But in this case, we're not, because of the complex path that these binary pairs have. Now, another point to note is that the star is never distorted due to the lensing. It simply gets brighter and then dims. And when they observed the star, they were not able to detect any UV or X-ray emissions in conjunction with the brightening event. Now, their current thinking is that the star that's being observed is a super-red giant, and this would be similar to Betelgeuse, which we have covered in some detail in a previous video. We can explain the sudden brightening event by a change in the incoming current or a change in the surrounding environment of the star. As these are brightening events, it leads me to speculate the latter. The question then becomes, why would the incoming current spike for such a short period of time? We've discussed the slow wandering of stars away from the pinch point, and this is clearly not happening here. Also, rapid changes in incoming current tend to cause at least a CME and at worst a supernova event. and CMEs are usually accompanied by increased UV emissions and X-rays. Clearly, the more energetic the expulsion, the more energetic the emissions associated with them. But here there is no evidence of increased ultraviolet or X-ray for at least one of the brightening events. So in this case, I would say that it is unlikely that the star is undergoing any rapid change in current density. Now this is where we start to go down the rabbit hole, because there is one piece of the data that seems to corroborate their concept, and it is much harder to ignore. And this is the fact that one of the telescopes that they used for this observation was the Gaia telescope, which is located about 0.1 astronomical units from Earth. And when they compared the changes in the received light during one of these brightening events, there was a difference of about 6 hours between the recorded peaks, and it was also a little bit brighter at the Gaia telescope compared to Earth. Now, in a lens model, this is predicted, as depending on your position relative to the lens would alter when you see the most magnification. So this is where the mystery deepens. I have looked at a number of gravitational lensed images, and in fact I've just finished a new one which should be out next week, and these images clearly show some sort of distortion in the field of view, and often show different types of reflection and magnification, which are not possible in a simple lens scenario. Something is causing this distortion. In the larger images, my speculation is that it is part of the outer structure of potentially a filament, some boundary condition due to the plasma which may be causing total internal reflection as it snakes away from the viewer. We also know the work of Dowdy Jr. that plasma can cause a lensing effect if the density is high enough. He demonstrated this with a limb of the Sun. The problem here is if we simply substitute the binary stars with plasma, would we get the same effect? Well, probably not. In order to create these periodic changes would require the plasma to be changing shape or density over a very short period of time. It would explain why it is invisible if this plasma is in dark mode. Now, another option is that the lensing effect is being caused by the limb of these two invisible binary stars. So similar to the gravitational lensing concept, but here it is caused by the plasma in the limb of these stars bending the light, which periodically would cause it to magnify when they line up just right. But here we would have to question, just as we did with the gravitational lensed image, why we don't see this phenomena around other binary stars. Now here the story would be slightly different to the gravitational lensed one, as this only relates to mass. Could these stars somehow have a much higher density of plasma compared to the other stars? It is a long shot. The fact that we cannot see them implies that they must be very dim. Another option would be along the lines of what I had identified in the images I've looked at, that some sort of total internal reflection or lensing is occurring at certain points, certainly boundary conditions. And in order to explain the changes in brightness, we would have to assume that it lies close to one of these areas, and that either the star is moving relative to the edge, causing it to periodically appear brighter when it intersects this, or that the filament itself is moving. The rapid events would be the object moving across a sharp boundary, and the slower, less intense ones would be it moving across a more gradually changing surface. The problem is trying to explain this motion on such a relatively short timescale. It is possible that the motion is also partly caused by our motion and its motion. At this stage, it's fair to say that no solution is satisfactory. Something very interesting is buried inside this mystery, but at this stage, I don't know how to unlock it. So let me know if you have any insights into what you think might be causing this mysterious brightening event. As always, be brave, be curious, the truth is waiting for us. Until next time.